So unit 6 is on our exponential and logarithmic functions. Just like all the other units we've done so far, you did this in algebra 2. We're just going to kind of like take it a step further and like deepen what your understanding was. So for an exponential function, that means that the variable is the exponent. So you no longer have like x squared or x to the third. You have like something to the x power. You have what's called a base number to the x. Does anyone remember what shape these are when you graph them? What they look like? I call it a swoop. It goes like, I will not deny to you, these are my favorite ones. I love this lesson. It's a swoop. It goes swoop. Okay. And have you ever heard like such and such grows exponentially? Like, what do they mean when they say something grows exponentially?
Goes higher.
Like really quickly, because it's like, okay. So it has a horizontal asymptote, not a vertical one. It's not like rational where you could have one of each. Okay, there's only a horizontal asymptote. And there's two ways it can look. So if you aren't sure, you got a 50-50 shot. It's either going to go up or down. Okay, so if you have your function looking like, and I'm just going to put a there, a to the x. A could be any number, like 2 or 5 or 17 or 54. Okay, something to the x power, that is called exponential growth. Exponential growth. It's getting bigger. You're ending up with more of what you had before. Do you remember 2 years ago in 2020 when COVID happened and the COVID cases grew exponentially? Do you remember this? Because like one person could infect 2 people and then those 2 people go out and infect more people and then those like, and it grew exponentially and the numbers went up really, really fast. Like if anyone looked at that data, do you remember those? Okay, growth. It means it's growing and it's growing very quickly, which is, usually not good. All right, or you can have, and there's 2 ways that can look. You can either have a to the negative x, or you can write it as a fraction 1 over a to the x. Those both mean the same thing, and we're going to have an in-depth conversation about negative exponents in just a minute to make sure we all understand that. Okay, that's called exponential decay. If you've taken chemistry or you're in chemistry, have you talked about like molecules decaying or like a half-life of something? Like where you had an amount and then you have less than you had before. That's okay. I'm seeing heads now. Exponential decay. Usually once you get to pre-calc, you've either had or you're currently in chemistry. Okay. So it either grows or it decays. It either goes up or it goes down. So we're going to practice stating the transformation. You have done this before. This is review. Here's the only thing you need to know. The base number doesn't cause a transformation. It's kind of just there. Okay. So when you look at letter A, the base number is 5. Do you see how it's 5 to the power of all this? The 5 doesn't do a transformation. It's kind of just there. All right. But what are the other transformations? Up, down, left, right, reflect. All right. Up 8. And I heard somebody say right as well. We went up 8 and right 3. Left and right is inside the function and it's kind of backwards. So it was right 3. We're just reviewing our transformations. That's it. It's just we're applying them to an exponential function. For B, what's the base? 3. So that's not going to do anything. And we have 2 other transformations. All right, down 4. And it's reflect over y. The negative is inside the function. So it's reflect over y. If you're like, hey, Miss Cole, what would it look like if it reflected the x-axis? I've got you. Look at letter C. First of all, what's the base? The 1/7, and usually it's in parentheses, so it's kind of easy to identify. The 1/7 isn't going to do anything. Do you see how there's a negative out front? Okay, that's going to reflect x. And then there's 2 others. So what else is going on there? Left 9, good. And if you multiply by a number out front, it's a vertical stretch. It's going to be like 4 times as tall. So not only is it going to grow really quickly, well, actually this one would be decay because of the 1/7. Not only is it going down really quickly, it would be like, oh, like what is the roller coaster Intimidator? It's like right down. That's what this graph would look like. Okay. So vertical stretch by 4. Now when you're doing exponents, it's just a good idea to know a lot of your exponents, okay? Because this part you don't get the calculator for. When we turn the page, like some of this other stuff, you're going to get a calculator for, but you don't get it here. So let's think about some of our perfect squares and cubes, because you do just need to know those. And I know you know them, but let's write them down again, okay? 1 squared, 1, good. 2 squared, 4. Let's just kind of like make our list. 3 squared is 9. And then what would be next? 16. I usually like to go up through 12. Hey guys. 25, good. 36. 49. 64. 9 squared is 81. 100. Good. 121. And I want to do one more. Good. If you know them further, that's super cool. I usually just say as long as you know through 12, you'll be in good shape. All right. And then the first 5 perfect cubes. All right. So 1 cubed again is 1. 2 cubed. Good. 8, not 6. 3 times 3 times 3. 27. 4 times 4 times 4. So be really careful with 64 because it's on both lists. It's 8 squared and it's 4 cubed. So just be careful. And then 5 cubed, 125. Again, those obviously go on infinitely as well, but if you know through 5, you're in good shape, okay? Now, I usually say you should know the 2s a little bit further. Do you remember when we did that, the binomial theorem and we did those expansions? Remember 1, 4, 6, 4, 1, we did all that? Okay, so a lot of you ended up memorizing some of the 2s as well. Do you remember what 2 to the 4th is? 2 times 2 times 2 times 2? It's 16. And do you remember 2 to the 5th? Good. Oh, well remembered. The 2s show up a lot because 2 is a little number, so it's good to just know those as well. Okay. Now we're going to have a conversation about negative exponents. Please listen carefully so I don't have to say this 9 million times. A negative exponent flips it over. That's it. It does not make your answer negative. It just flips it. Or the, true word for that is it reciprocates. Okay. So when you look at this, what's 3 squared? 9. But because it's negative, your answer would be 1/9. It's not negative, it got flipped. You do learn this in Algebra 1, but that was a long time ago. So we're just going to take a minute and review these, all right? 4 cubed would be 64, but because it's negative, 1 over 64. So how about this one? 1/49. Good. Now you're going to flip the 1/5 and it would just be 5 cubed 125. So again, the negative exponent just means that you flip it. That's all. So this negative, you're going to flip it. It would just be 9 squared. Good. 81. So a negative just means you flip it. That's it. Now, if you have a fraction exponent, those are your roots. So a 1/2 means square root. You did this in Algebra 2. Yes? No, it's all evaporated. Well, that's why I'm going over it again. The 1/2 power means square root. So 36 to the 1/2. 6. Good. All it means is square root. All right. So 49 to the 1/2 is 7. If the 1/2 means square root, the 1/3 means cube root. Good. So this means cube root of 8, which is 2. Now, this I know, like, oh my gosh, it's a 2/3 instead of a 1/3. Pretend it's a 1/3. Hold on. Pretend it's a 1/3 like we just did. 8 to the 1/3 would be 2. This means that you square it. So 2 squared is 4. So it was a cube root. Pretend it's a 1/3, and then you just square that. And then 16 to the 1/4. That means a 4th root of 16. It would, some of you are saying it already. It means this, which would be 2. That's why I brought up the 2s. I like to go a little bit further with them.
What? No, never mind.
All right. Now I usually get asked, hey, what happens if there's a negative base? Let's just look at that real quick. Let's try and fill in this table if the base was a negative number. Okay, and I'm actually going to start over here and work our way down because the negative ones bother everybody, so we'll save them for last. Okay, so let's plug in 3. -2 to the third. And if you don't want to write them, that's fine. I'm just going to show you what it looks like. -2 to the third. Good, -8, because it would be -2 times -2 times -2. Now, if you plug in 2, it would be -2 squared, which would be 4. And good, it's +4. How about -2 to the first? -2. Okay, for 0, think first. Like, use brain, then speak. Okay. If you plug in 0, anything to the 0 power, good, is 1. 1,000,000 to the 0th power is 1. That's just how that works out. All right, now if you plug in a -1, the negative exponent means you flip it. Okay, so this would be 1 over -2 to the first. You're flipping it. I get that that's complicated because there were 2 negatives in it. That's why we're going over this slowly. All right, -2 to the first would be -2. So the total answer would be -1/2. You're just flipping it. If you plug in -2 to the power -2, it means that you're going to flip it. It would look like this. So what would that give you? 1 over 4. And do you see what we're doing here? Do you see how this is -2 and this is -1/2? And this is 4 and this is 1/4? So what's the next one out going to be? Why does it not work? This is bad. Like, you should go, hey, something's wrong there. If you tried to make a graph out of these numbers, like if you tried to plot this table on a grid, why would it not work? Negative, positive, negative, positive, negative, positive. If you tried to graph them on a grid, it would be down here, up here, down here, up here, down. Like, you would, and blah, 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 blah. It would look like it would just spaz out. It would not work. You cannot have a negative base. For this reason, the numbers are going to alternate. It's called oscillating. It won't work. You could not connect them. Here's what's going to happen though. Next week, and I totally get why this happens, and I'll answer you. It's totally fine. It's like my job. But next week, someone's going to raise their hand and go, why can't we have a negative base? My prediction. It's my crystal ball. I've been doing this a lot of years. Someone's going to raise their hand and be like, why can't we have a negative base? Please try to remember that this is the reason why, okay? For me. All right. We're going to try a couple graphs and I'll give you a break. I love these though. They're the easiest graphs in the world. It's a little swoop. And then doing your characteristics is super easy because this is like the bread and butter of algebra 2. Do you know how every unit for algebra 2, you do this for a different graph? It's pretty much what we've done this year too. Get your graph and then this will be super easy. What direction did this shift? Up or down? Down 4. So you're going to go down 4 and dot in, and we are going to do the left one. That's why I reviewed the transformations. But do the asymptote first. It went down 4. And then you can even write that over here as like your answer. Do that first. That's my suggestion. Asymptote first. It went down 4. It's y equals, oh, I'm sorry. It's not y equals 4. Oh, blasphemy and sacrilege. It should actually be y equals -4. Thank you. Oh my goodness. That was almost a disaster. Yeah, exactly. Just being silly. Go ahead. Yeah, good. Oh, is there a vertical asymptote? No, so none. Or nope, or NA, or a frowny face, or anything silly that you want to write, but there won't be one. So the reason that that's on there, let's have this conversation. The exponential ones have a horizontal asymptote. When we get to logarithmic, they're going to have, and you have to know which one's which. Okay, so, but for these ones, vertical will be none. That's the answer. Or whatever you feel like putting on that line, it will have a horizontal asymptote. Now let's make a little table. Who was it said the left one? Whoever said that, that's a good idea for us to start there. See how it went left 1? Let's start by plugging in -1. That was you, right? All right, let's plug in -1. Y'all ready? Buckled in? -1 plus 1. 0. Good. Anything to the 0 power is 1 minus 4, -3. I want at least 3 points. So let's try and come up with another number to plug in. Picking something near -1 would be a good idea. Good. Let's do 0. 0 plus 1. 1. 2 to the 1 is 2 minus 4. Awesome. And then let's do 1. You just got to be clever about what you're plugging in. Oh, the pep talk from like the first week of school. If you pick something that doesn't work out pleasantly, what do? Try again. Pick something else. It's not a big deal. All right. 1 plus 1. 2. 2 squared. 4 minus 4. 0. Plot those. It should be a swoop. Hey, is your graph swooping over there? Now, once you have the graph, my sincere hope is that filling out all this stuff will be the easy part. I hope I can, bless you, I hope I can call that the easy part, okay? Because you kind of just look at that and answer it. It's not a complicated graph. You have done way worse ones this year. Do you remember the polynomial graphs that went up and down and all over the place and did all sorts of crazy stuff? And these are very basic. What's the domain? Yep, everything. It's going to go left and right forever. Hey, Miss Cole, is that the answer for all these? Yep. That's the answer. Foreshadowing, though, when we get to logarithmic, it'll be the range that's all reals. If they're inverses, it's going to flip-flop, okay? What is the range of this graph? Sweep downwards to upwards. Good. Bracket parenthesis conversation. It will be -4 to infinity. What does -4 get? Why is it a parenthesis? It's an asymptote. It won't ever actually touch. It'll get closer and closer, but it won't ever actually get. X-intercept. 1, 0. You kind of just look at it and go, there it is. Y-intercept. 0, -2. It will either increase or decrease. These don't turn around. So what's this one doing? Yep. Increase will be everything. Decrease will be none, or whatever silly thing you feel like writing on that line. And then your end behavior. It's not hard. You just have to remember how to write it. But you guys did great with this on the last test where you had to do this. Limit x goes to -infinity of the function. Limit x goes to +infinity of the function. And it's just, what's the left side doing? What's the right side doing? One side will level off. The other side will either go up or down. That's how these will always turn out. So where does the left side go? -4? Will it ever touch -4? No, it's behavior. Where does the right side go? Yep. Up, +infinity. We're just going to try one more of those and then we'll do a break. We'll speed it up for this one. Did it move? Oh, did we all get that? Or are we okay? Okay. Did this one move up or down? Up 3. Dotted in at up 3. And then you can put that information on your list right off the bat. And it's y equals +3 because it went up 3. And then if you want to put that the domain is all reals, you can do that too. That's like going to be the answer. And then we'll make a little table of values. You want to be clever where you start. Did this move left or right? Went right, 2. So start with 2. Start wherever it shifted. Here we go. 2 minus 2. 0. Anything to the 0 power, 1 plus 3 is 4. Oh, wait, I'm sorry. Did I lose another? Oh my gosh, geez, it's Monday morning. Let me try again. 2 minus 2 is 0. Anything to the 0 power is 1, but it is -1. Thank you. -1 plus 3 is 2. I would have caught that because the graph wouldn't have swooped. It wouldn't have made sense. It would have looked weird. All right, now we need another number to plug in. You want to pick something close to 2. 1. Let's do 1. 1 minus 2. -1. It's a good thing it's negative though, because a negative good, perfect. It'll make it a whole, I usually have to pull that out of everybody, but you guys are on top of it. So it'll actually, instead of 1/3, it'll be 3, but it's actually a -3 plus 3 is 0. It's okay, we're gonna do it again. If you plug in 0, watch. 0 minus 2, -2. Now the fact that it's negative flips this over. Well, you take it to the second. So 3 squared is 9, but it's -9 plus 3 is -6. Okay, go ahead and plot them. It should swoop. People usually want to know, like, how hard can you make it? That's probably about as hard as I can make it. Fractions bother people and negatives bother people. And when there's negatives and fractions, it's like, I get it. Totally get it. Oh, but here's the other pep talk to this. If you struggle with the graph, what do I always tell you to do? Make something up. I'll take off for the graph, but if all of this information matches what you put, you get credit for all this. Do you get what I'm saying? Don't ever leave it blank. Make up a swoop. Invent one. I don't. Yours look good. That's fine. All right, range. Downwards to upwards. What's our range going to be? Good. -infinity to 3 with a parentheses. Good. X-intercept. You kind of just look at it. 1-0. I like that. Y-intercept. 0, -6. One of these will say none. What is this doing? Increasing is everything. Decreasing is none. And then you've got your limits for your end behavior. And so again, one end will level off. One end will either go up or down. So where is the left end going? Down. So we'll say -infinity. And the right end is going to 3. So the reason that this next topic fits in here, the compound interest formulas, is because they are exponential functions. That's why it fits in with this unit. Disclaimer, I'm about to write up a whole mess of information here. Just write it down, trust the process. I will explain to you what everything means. And the first thing everyone asks is, do I have to memorize this formula? Yes. And it's going to look complicated at first, but you're actually going to be okay. I get everybody through it every year. Do you understand me? Okay. So it is A equals, it's going to look like the alphabet threw up on your paper here in a second. P parenthesis 1 plus R over N to the power NT. I'm going to tell you what all those letters mean. I guess technically no, but they usually are. Yeah, I guess capitalizing in lowercase is sort of up to you. All right. Yeah, that's an NT. And I usually say int to be silly, and that helps everybody remember it. Okay. A is the amount. That's the amount you end up with. We're going to be talking about dollars, cash money. Okay. This is like you put money in a bank and it accrues interest, or you owe money on a loan and it accrues interest, which is more often the case. You know what I'm saying? Okay. A is the amount you end up with. P is the principal. That's what you start out with. That's like the amount of money you would put in the bank, or the amount that you start out owing on your loan. I think I made all these problems about like you're accruing interest, but again, more often like you're going to be, you understand that like when you go to college, you're going to take out loans, and then when you pay it back, you're going to have to pay interest. Or like when you buy a car, you're going to take out a loan, and when you pay back the loan, you're going to have to pay interest. Or when you buy a house, you understand what I'm saying? Yeah. So they're going to take your money at whatever opportunity. Okay. All right. P is the principal. R is the rate. That's the interest rate that you get. If you're making money, it's better for it to be bigger. If you're having to pay back money, it's better for it to be smaller. Now it's called compound interest because it's like you're compounding the interest. N is the number of times the interest gets compounded. Sorry, I can't talk and write at the same time. What I mean by compounded is this. You roll over the interest into the total. So if you are making money on something, it's how many times per year they take that interest and add it into the total. If you're trying to make money, the more times you compound, the better. Because if you take that money and add it into the total, you're now taking a percentage of a larger number. Does this make sense? Okay, so the number of times you compound. If you compound annually, N would be 1. Annually means once a year. Let's write this down. Annually means 1. N is 1. Once per year. If you do semi-annually, N would be 2. If you compound quarterly, what do you think N would be? 4. Good. Okay, cool. And then monthly, N would be 12. Okay. Semi-annually is the only one that's kind of weird. Annually, like annual, once a year. Okay. Quarterly is 4, monthly is 12. Semi-annually is the only one that's kind of weird. You are just going to take all the ingredients and put them into the recipe and then type on your calculator. Boom, you get an answer. Okay. Oh my gosh, we're going to get to that. Just hold that thought. Okay, hold on to that. Find the amount present in an account with the principal of 700, interest rate is 3.5%, compounded quarterly, 5 years. Those are all your ingredients. You're going to take them and put them into the formula. So it's A equals, what is P? What's the amount? 700, parenthesis, 1 plus, what's our interest rate? Okay, listen, if you put 3.5, you're going to end up with like $1 bazillion and you're going to go, oh, whoops, that was a mistake. It's good. It is going to be 0.035. You scooch the decimal point twice because it's out of 100%. So you have to scooch the decimal point twice. Again, if you forget to do that, you're going to catch it because you're going to end up with like millions of dollars like you won the lottery and you're going to hopefully go, hey, that's not right. Go ahead. What's that? Or, oh yeah, I'm sorry. I forgot to say that. T is time. T is time, number of years. Sorry, I guess I didn't say that because I felt like that one's obvious. I apologize. Yeah, T is time. T is number of years. Okay, over N. Now it says compounded quarterly, so N is 4. And then it's to the power NT. And again, I'm sorry, T is time. I guess I just always feel like that one's sort of clear, so I don't write that one in. So anyway, to the nth power. So we said N was 4. And T is, how long are we leaving the money in there? 5 years. Everybody, go ahead and slap that in your calculator. Put a $sign for cash money. And you will get your answer. Now, you should get something slightly more than 700. Does that make sense? Like if you start with $700 and you compound interest, like you gain some interest, you should get something slightly more than 700. If you want to get that fancy fraction bar on your calculator, it is alpha y equals. Alpha y equals enter will give you that fancy fraction bar. Alpha is right below second. It's on the left side. If you hit alpha y equals enter, it will give you that fancy fraction bar, which you do want to do that because it's the top left. 700, parenthesis, 1 plus, you're going to type it the exact way it looks on your paper. And then alpha y equals enter will give you the fraction bar. Enter. Alpha y equals enter will give you the fraction bar. Did you get an answer? It should be something more than 700, but not like $1 billion. Do you know what I mean? It should be like a little more than 700, but not like $100 million. Now let's talk about rounding for a second. And we're going to talk about this more like later on this year. For AP Calculus, and I teach this class as though you're all going on to AP Calculus, even though I know you won't, but like I know some of you will, so I have to explain it this way. For AP Calculus, it is always 3 decimal points. But for money, we'll go ahead and do 2. But if you want to do more, if you want to do 3 decimal points, that's fine. I got 833.24. Does anyone have the same thing? Perfect. Okay, let's try it again. So I just said for AP Calc, you'll need to do 3 decimal points, but for money, I'm fine with you doing 2. But if you want to put 3 to start getting used to that, you can put as many decimal points as you want, actually. You know, for gasoline, it's actually to 3 decimal points. Did you ever see that little 9 at the end? Because they actually charge you 9/10 of a penny. It's like whatever it is, and then 9/10 of a penny. Taxes. Great. All right, let's try number 9. A equals. What's the principle? You just read through and find it. This is like if you had $1,000 that you had nothing else to do with, you wanted to stick it in a bank account. Also, to be clear, you realize you will never get a 3.5% interest rate on a savings account, right? You will not. You will get like 0.1% interest rate. Like this won't happen in real life, right? Parenthesis, 1 plus, all right, what is our interest rate for this one? Yeah, 0.10, which again will never happen unless you're owing money, then they'll give you a 10% interest rate. That's whack is about the best way to say that. Over n. All right, what is n for this one? 2, good, because it says semi-annually, and it's to the power nt. N times t, so that would be 2 times however many years, which is 3. Go ahead and put that in the calculator. Make sure you can type it, because if you can't, you will not be able to get these answers on your test. All right. 1,000 parenthesis 1 plus alpha y equals enter. We'll give you the fraction bar. And you should just type it exactly the way it looks on your paper. And you should end up with something bigger than 1,000, but not like a 200 billion. Do you get what I'm saying? Like it should be a little bit more than 1,000, but not like a crazy amount. What's that? Did anyone get $1,340 and some change? No. So yeah, so 0.09, you know what, I'm going to do this. I'm going to do 3 decimal points, or you could do 0.10, like 10 cents. Again, however you want to round that to 2 places or 3 places is fine with me. Now I'm going to kind of speed this up, and I want you to do, because I want to push us through and end a little bit early so you can have time to like debrief here at the end. The other formula, and actually someone brought it up over here already. I'm gonna ask if you guys did this last year. What happens if you compound continuously? Like all the, or did you do it EPS? Oh, okay. Well, we'll see who remembers this. What happens if you compound continuously? That means you want to go out forever. You want n to be infinite. What happens if n goes to infinity? Now we're just going to look at this one piece of the formula. And I'm going to let the rate be 1 for this experiment just to simplify things. So I'm going to let R be 1, and we're going to look at just this part. So 1 plus 1 over n to the n power. And I'm going to type it in. I want you guys to just watch, because again, I'm going to try and speed this up here a little bit so we can have some time at the end here. Oh, whoops. So I typed that in. I used X instead of N just because it's easier. I have an X button. We want to look at what happens as this gets bigger and bigger and bigger and bigger and bigger and bigger. So if I go to my table and I start scrolling out, as the numbers get bigger and bigger, do you see how it keeps changing? Okay, that means I'm not counting high enough. So if I go and change my table, instead of counting by ones, if I count by hundreds, do you see how I changed it to 100? Now, when I count, see how the table goes 100, 200, 300, 400? Do you see how the numbers are still changing though? like very slightly this time, but I want to get to a point where it's leveling off and they're not changing at all. So let me go back and change it to 1,000. Now we're going to count by thousands, and I think it doesn't change anymore at this point. There, do you see how it's the same? That's where it's leveling off. 2.718 is where this is going to level off. That is called the number E. E is 2.718. It is exactly like how pi is 3.14 da 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 da. Do you get what I'm saying? How pi is 3.1415. I don't know it any further than that, but do you get what I'm saying? We call this number E. Once again, I know that next week someone's going to raise their hand and go, why is E 2.7? I'm going to be like, because as you go out to infinity, that's where the numbers level off. I didn't make it up. It's just the way it is. Do you know why pi is pi? Like why that's 3.14? Like where that comes from? So it's circles. Good. I'll take that. If you take any circle, big, small, medium, it doesn't matter. If you take the circumference divided by the diameter, you get 3.14. That's just what, like, it just is. No one made it up, it just is. And it's the same thing with E. This is just that number. So if you are compounding continuously, this is your formula. And no one usually has any trouble remembering that one because it's PERT. Is that familiar in any way? It was brought up over here that you like did see that before, or maybe in chemistry. So if it says continuously, you use the PERT one. So let's try these two. And I made them the same numbers as the previous ones, but I changed it to continuously so we could do a compare contrast. What is your principle for this one? 700. And look, do you see how it says continuously? That's what tells you that it's the PERT formula. So if it says annually, semi-annually, monthly, quarterly, you use the first one. If it says continuously, you use PERT. All right, it's e to the power r, which is 0.035 times t, which is what? What's t? 5. And I'm going to show you how to type it in the calculator. Because you just set it up and type it in the calculator. Okay. So type your 700. And then I want everyone to watch so I can just do this once instead of over and over again. Do you see this button right here that says LN? We're going to learn that eventually this unit, okay? Do you see how right above it, it says E? Yeah. So since it's right above it, what do you have to hit? Hit second LN. And do you, oh, whoops, 700, second LN. And do you see how it put E on your screen? Do you see how it also did the exponent for you? Cool. Now you're just going to type the rest of it. 0.035 times 5. Please type this along with me. Typing it is a skill that you need to have. Otherwise, you can't get the answer on your test. And you should end up with something slightly more than 700, but not like 400 billion. Okay? I saw some of you just watch me do that, but not type it in. I don't know what to tell you. When I hand you a test, you're going to have to type it in. Did you get 833.87? Yeah. Okay, I'm hearing yes. So I'm assuming I typed it right. Now here's the compare and contrast I wanted you to do. Do you see how this problem and this problem had all the same numbers, except this one was continuously? I know it's not a great big difference, but which one's more? Continuously is going to give you more money. Now this one's going to be a more like drastic difference because your interest rate is higher. 10% instead of 3.5%. So what was our amount for this one? It was 1,000, right? And do you see how it says continuously? That means it's E, which is 2.718. Okay, remember E is a number, to the power R times T. So 0.10 times 3 years. Type it in, please. And you should get something slightly bigger than 1,000, but not like hundreds of billions of dollars. That would be too much. It'd be great. Those of you flipping your paper over already, did you get this number? $1,349 and what are we going to call that? 86 cents. All right, here's the compare and contrast I wanted us to do. Do you see how when we compounded semi-annually, it was this 1340? Do you see how continuously it's a little bit more? Okay, And then we're going to do 2 more of these graphs. Again, these are the easy ones. Now the calculator gets taken back away for these. You don't get a calculator for these. But do you see how the base is E?
Sure.
Instead of 3 points, you will only be able to get 1. It is. I feel like it's less work, really. Did this graph move up or down? Do you see anything like, oh, it did move left or right, but did it move up or down? No. Okay, perfect. So that means your horizontal asymptote is still at 0. It didn't shift. Yes. Yeah, for the rationals, I usually just do it on the edges. These ones, it's the only asymptote there is, so I just. But you're not wrong. Technically, it is just the end, but I just put it the whole way through for these ones. All right, now you will only be able to get 1 point here because without a calculator, the only one you can do is e to the 0. What is anything to the 0 power? 1. Unless you can do 2.718 squared in your head without a calculator, 2.718 cubed without a calculator. No? Okay, you're only going to be able to get 1 point. Now that doesn't mean you plug in 0 though. In this case, what would you plug in so that you end up with a 0 there? Good. Okay, if you plug in 5, 5 minus 5 is 0. Anything to the 0 power is 1 times a half is a half. So the only point you get is 5 comma a half. And this is usually where everyone stares at me and goes, now what? All you have is 1 point. The graph either goes up or it goes down. Do you see a negative anywhere in the equation that would have flipped it? No, so it goes up. All right, so it should be doing something like this. So it either goes up or goes down. Those are your only options. Once you have the graph, this is the easy part. And if you can't get the graph, what should you do? Make it up, because you can get all the points for this. What's our domain? All reals. Range, you want to sweep downwards to upwards. Perfect, with a parentheses. X-intercept? None, good. Y-intercept, oh, this is kind of cool. You get a y-intercept by plugging in 0. Ready, watch, I love this. Some of you are going to love this and some of you are going to hate it, but just get on board. If you plug in 0, 0 minus 5 is negative 5. So it's 1/2 e to the negative 5, whatever that is. That's some kind of decimal. It's 1/2 times 2.7 to the negative 5. Without a calculator, I don't know what that is. So you leave it like that. Isn't that great? I love it. Just leave it alone. All right, are we increasing or decreasing? All right, increasing, decreasing is none. And then set up your end behaviors. I love the exponential graphs. They are absolutely my favorite ones. They're just real basic. It's just whoop. Yeah. I'm all about giving more hugs. So where is the left end going? 0, right end, infinity. We're just gonna try one more. You got it. And you'll still have over 20 minutes left over. Don't stop listening to me when we're done. I'm going to show you delta mass so that you know what it's going to ask you, because it's really easy, but I want to make sure you know what buttons to press, right? Did this graph move up or down? Moved up. 3. Do you guys see that there? And you are only going to be able to get 1 point, which is kind of a bummer, but also sort of cool. It's like less work, but then you only get 1 point. So what do you want to plug in? There's only one number that's going to turn out nice. 0 in this case. If you plug in 0, you can't negative a 0, so it's still just 0. E to the 0 is 1 plus 3 is 4. So you get 0, 4. And again, this is the part where everyone stares at me and goes, now what? You only have two choices. It either goes up or down. Do you see a negative in the equation? Yes, so it is going to be reflected and it's going to be going down. So like that. Like the intimidator. All right, once you have the graph, this is the easy part. Domain, all reals, that like is the answer. Range, you want to sweep downwards to upwards. Close. 3 to infinity. X-intercept, oh, again, there isn't one. Y-intercept is 0, 4. And then what do you guys think for increasing, decreasing? This is none, and this is everything. And then the ends. So where does the left end go? Well, yeah, as we go to negative infinity, where's the arrow pointing? Yep, infinity, it's going up, and then the right end, 3.